What's up, guys? How you doing? It's Graig Weich from BeyondComics.tv. I'm a comic book artist, writer, and film director and creator of these guys, codenamed Justice and Ravedactyl. I'm here to tell you an idea that just kind of came to me, and it kind of came to me in a similar way that some of the other things I create came to me. And by no means am I a scientist, but I think I've actually cracked the code for how people, human beings, can actually see into the past as far back as the first moment of creation, whether that be of the universe or of human beings or anything along these lines, as long as light has been reflected from that creation in some capacity. I don't know if this has already been thought of or not. I have not checked it on Google or anything. I'm not even sure how to check this, but I'm going to put the idea out here, and if I am the first person to think of it, then this is copyright and trademark and patented by me. Okay, here we go. So here's the situation. Basically, I'll start a little bit small. As many of you may already know, it takes about roughly 8 minutes or so from the light of the sun's fire to travel to Earth. The distance between the sun and the light that's coming from it to travel all the way through space into where we are as human beings observing it with our optics, right, on the planet Earth. Okay, so this sounds bananas, but bear with me. So basically, you are seeing, for those of you who don't know, I'm going somewhere with this, you are actually seeing the light of the sun 8 minutes later than it actually appears. So what we are looking at right now, if we're looking up at the sun right now, we're actually seeing an 8-minute delayed image. So if the sun has already gone down, so to speak, and is away from our vision, we will still see it for an additional 8 minutes until that light of it going away comes to Earth. So there's an 8-minute delay. Now this is just basic knowledge that I think a lot of people probably already know, and you can Google it and get the exact time and measurements and stuff there. But that concept had led me to do some interesting kind of thoughts, and I started to see some other things online and different things announced, just randomly coming across it. And then they have a picture of the Hubble telescope and how it recorded multiple galaxies that were light years away from Earth, meaning it would take light years or millions of years for the light, or I think it was 350 years actually, for the light to travel from that distance of the furthest galaxy that the Hubble telescope was able to capture to Earth, where people can observe it and see, right? So that seems to be the distance of time, 350 years or so roughly, from the light that was reflected from those galaxies to travel all the way across the universe. Took 350 years for that light to travel. So the photo and the image that the Hubble telescope actually captured was an image that's 350 years old, even though we're seeing it live for the first time now. So think of it as a video broadcast signal, if you will, that's taking 300 plus years for that video broadcast signal to travel all the way from the farthest regions that the Hubble telescope can see of the universe all the way to where we are on the planet Earth, right? So, I mean, if you really start thinking about the concept that we as human beings are existing on a floating blue-looking orb in the middle of space, or wherever it's located in space, is already astounding, and it's mind-blowing and definitely above our pay grade, so to speak. But this concept started to make me think, well, wait a second, if we're able to have a telescope capture an image that's 350 years old, including our ability to be able to witness and see a star currently, right now, from Earth, without a telescope, in space, that may have already exploded or died out and does not exist anymore, but we can still see it. We can still see that star. Again, it's taking we're able to still see it because we're seeing, like, almost, if you think of it like a pre-recorded image of that star traveling down to what our eyes perceive and how we perceive the reflection of light. For example, if there was no light in this room, obviously it would be pitch black, right? And you would not see me. But the light, you're actually not seeing me, you're seeing reflective light reflecting off of my hands and my face and my body and off of these things into the camera where you guys are looking. So that gives you a perception that your brain pieces together of this image and this visual. So if you take that same concept, like I'm saying before, and you pull it all the way from the Hubble telescope that's being able to see an old star, or you yourself seeing an old star that may have already exploded, we're seeing the image as if it's still there because we're just receiving that visual signal. I think you guys are on the same page with me and understand what I'm talking about right now. If not, definitely Google it or YouTube it. I'm sure there's a lot clearer videos on that aspect. But this led me to think that that means that space itself is recording information, mathematical information that's carrying this knowledge of visual recordings of the entire universe everywhere around us simultaneously and projecting it outward, right? So whatever the source is, if there is light that reflects off of it, that's being projected outward somewhere. Then obviously you need to have a receiver. In this case, our human bodies with eyes are receiving that light and understanding this information coming into our optics, right? And then our brain processes it, etc. So what am I talking about? Here's what I'm talking about. So the idea is that what if that information, that, again, if you take a star that exploded 350 years ago and we're just seeing that star live for the first time, that means that that video broadcast signal, so to speak, of that image is still alive and traveling through space until it reaches our vision to have it interpreted, right? So that must mean that one day, as we are able to eventually build more powerful Hubble-type telescopes, named after the guy who created it, that should allow us the ability to see or find and locate the information of light that is carrying the information of the first creation of the universe, somewhere, wherever that is. You understand? So the first thing that was created, that light reflected off of, is recorded and traveling somewhere in the universe, waiting to be discovered. If you guys research someone by the name of Quimby, Phineas Quimby, he's a genius from the 1800s. And really needs more publicity because he's an amazing person. But he has a real deep understanding of some of this type of stuff. And I think that what I'm talking about and what I've kind of think I've discovered here can fit with a lot of what he's talking about with things existing, whether or not it's perceived by a human being. It already exists. But that's a different story. We'll talk about that at a different time. But the idea is that the first thing, going back to that first thing I said, the very first thing that's been created in the universe that has light reflecting off of it, or some type of information that's being recorded through space. In this case, we're using light as an example that's realistic and has already been quantified. That light is emanating off of that object, whether it's a star, a planet, a person, whatever it is, that it's being reflected off of that person and recorded in the cosmos, in the universe, waiting for someone like a human being with eyes and a brain to be able to perceive it. We have to now figure out how to locate that information that is being held within the light spectrum that's being broadcast, if you will, to where we are. You see what I'm saying? By the way, this is something I just thought of like literally a few minutes ago, so sorry that I'm kind of stammering and all over the place, but this is kind of the creation process. It's this type of thinking that, you know, got me to create these guys here and, you know, my comic books and some of the stuff that, you know, I've spent my life creating and things like that. So this is kind of how it happens. It's a little bit messy, and then we have to kind of edit it and tighten it up until you see what, you know, what I've created here. Anyway, the idea is that if this information and light can carry information, basically. So that means we have to, again, like I said before, locate where that first light comes from and how old it is and how we measure that distance and that time and how time relates. I mean, time is a concept to measure, you know, distance and all this stuff we can talk about forever. But the idea is that if you can imagine that, that's a huge discovery, to think that the first thing that was created that had light reflecting off of it is recorded somewhere in the universe. That means we can travel somewhere eventually and find somewhat of a video broadcast of light that holds information that will appear as if it's just happening to us, like a videotape being played, even though it may be billions of years old, not just millions. So that's tremendous. So if we can, again, the Hubble telescope is now able to travel, to see far enough into space where it can see images of galaxies upon galaxies upon galaxies that are already at least 300 plus years old. So imagine a few hundred years from now or whatever, as they start developing further technology, or if they could start understanding how to utilize black holes and things like this and travel or connect, you know, Brian Greene's theory of string theory, put that all together. Anyway, the whole thing, and here's what's important too. My question is, can this imagery or this recording of light information be interrupted if something is created in front of it? Quick example, and let's actually take this in order. Let's say right here, this is the first object. All right, let's use one of these action figures here. We just created this character that I helped design, Gakito, based on the comic book, if you can see it. All right, so we just printed this out based on the art we created. So let's say this was the first thing, this represents the first thing that was ever created, okay? Let's just pretend. And light is reflecting off of it, and let's say that first thing might have been the first planet, the first person, the first whatever you want to call it. This is the first creation. Light's reflecting off of it. Now, millions upon millions of years, more than 65 million years, let's take it to 100 million years, go by, okay? And that information of that light is bouncing off of this object, let's pretend it's a planet, for example, and it's traveling through time and space, all right? 100 million years ago. If we get a telescope that can see into that level of distance, we should be able to eventually, even if we don't, by the way, let me say this too, even if we don't get a telescope that sees that deep, eventually that light signal, if it's not interrupted, will reach, however 100 million years it takes to reach us, eventually it will reach planet Earth. Let's say that I'm representing the planet Earth right now and I'm seeing it recorded into my eyes, right? And it looks like it's happening live. And now I say, oh wow, look in space. I see the creation of this first planet. We wouldn't know it's the first planet, but we're seeing it. Now, when you measure it, and then you take the new telescope that we have to assume will be invented, boom, it sees that, oh, there's nothing there. This is light that's actually recording the image and broadcasting it to us. Therefore, that means that we're seeing 100 million years into the past for the first thing that was created. In this case, we're using the example of a planet, right? This action figure represents a planet. My question is, as this light is reflecting off of this object, heading our way or multiple ways, what if something is created, like a star develops or whatever, that actually blocks that signal? So let's say, like, we take Justice's ninja star over here, right, the Shuriken ninja star, and let's say here's the light signal traveling from the planet, it's heading our way toward Earth, but then a star suddenly develops, or a fragment of it. Boom, now it's blocking the light signal. It cannot penetrate or pass through the star. Therefore, we as human beings would have to travel or get on a satellite and then put a Hubble telescope or something like that, or a new powerful telescope, to go in front of that thing or this object that's blocking the light signal that carries the information. Once we go in front of the blocked object, now the light is free to travel toward the telescope that we've now created. Do you guys understand what I'm saying? My God, I can't wait to hear the feedback on this. Everyone's going to think of bananas. Okay. Anyway, this makes sense to me. I would love your feedback, guys. I want to hear if it makes sense to you. It's an interesting process, being a comic book artist and a writer and creating different ideas. And even if this is completely factually wrong, it still makes for an interesting concept and something that I think people can really gravitate toward. But I do think that there are elements of realistic possibilities and truth in some of the ideas that I'm talking about right now. And it'll be kind of exciting to one day potentially take those ideas and formulate them into something concrete and tangible, you know, like a comic book where we can actually, you know, play along and see some of the different cool characters and some of the creations and things that, you know, develop out of, you know, these ideas. So it kind of starts with this kind of crazy pot of all these ingredients. And what's interesting is that if one ingredient is left out, it doesn't taste right. It's like typing an email. If one email address is wrong, just one little digit is wrong or one little character is wrong, you can't send the email to who you're sending it to, right? So it's the same process in trying to figure out these calculations, but they all start with crazy, you know, very outrageous ideas and things that might sound laughable. But remember, everybody that was made fun of, including Stan Lee, the creator of course, Marvel Comics' Spider-Man, tells a great story where he walked into his editor's office and he said, "Hey editor, I have a great idea for a new hero called the Spider-Man." And the editor said, "That's the stupidest thing I ever heard in my life. Get out of my office." Then they did a comic book series called Amazing Fantasy. And on issue number 15, the editor came back to Stan and said, "You know what? That Spider guy, whatever the hell his name is, we'll put it in this comic book because the series Amazing Fantasy is ending. It's the last issue. So we'll throw it in there because we need a filler." So Stan said, "Terrific." And he put Spider-Man into Amazing Fantasy issue number 15. And it says, and I actually had the original signed by Stan, but it actually says, Amazing Fantasy 15 introducing the Spider-Man, right? And it was the highest selling comic book at that time. And the editor came back to Stan after they got the sales figures and said, "Hey Stan, how you doing? Remember that great idea we had?" Well, it's the great new comic book Spider-Man. Let's keep going with it. So it's just kind of funny to hear how people can be made fun of, how Albert Einstein was mocked and made fun of, and look what he's created. So again, for any kids who are watching out there, for any young people in school who are trying to make it, if you're made fun of, if you're bullied, if people mock you, if they laugh at your ideas, if they think you're crazy or stupid, well, hey, look at me. I created these superhero guys and I'm doing okay, right? So maybe you'll create something one day too. Anyway, thank you guys so much for watching. Please make sure to subscribe, and I will talk to you soon. Graig Weich signing out.